Hi guys, welcome to this next video. We're going to be looking in this one at surface area, part of the measurement unit. Okay, surface area, your learning goal is that students can calculate areas of shapes and the volume surface area of right prisms and cylinders. Remember that a right prism is, when you've been given a, for example, this kind of rectangular prism thing, the base and the projection dimension is a right angle. Okay, so that's what we mean by a right prism. Okay, at the end of this video, you want to be able to deconstruct a solid surface into its net and calculate the surface area of a given solid. All right, 3D to 2D. Okay, so here's where you're going to want to really exercise your spatial reasoning skills, which is good. It's an area that sort of will improve every area of your mathematics if you can sort of really exercise this aspect. Okay, so what we mean by this is we need to be able to take a three-dimensional object. So let's say this rectangular prism that I've drawn here. Okay, and we need to take it from its three-dimensional perspective to a two-dimensional, like flattening out of all its different bits and pieces. Okay, so we can kind of think, okay, there's back, front, left, right, up and down, and so you could probably see that we've got one here, the bottom part, and the four sides are folding out like a box, then the very top part again on here, and so you have 1, 2, 3, 4, 5, 6 different pieces. Okay, now you need to not only be able to do that for sort of reasonably simple shapes like that, but also thinking about pyramids. Okay, so one's like this, and so remember that would have a square in the middle with the triangles out to the sides, and maybe thinking about cylinders is another big one you need to be able to work with. Okay, remembering, so now for this one the net would be sort of this rectangular piece that would have these two sort of circle pieces sort of stuck onto the end. So you think about, if I wrapped this thing in paper and then perfectly and then took the paper off and put it on the ground, what would that paper look like? That's this idea of taking this three-dimensional solid to its two-dimensional surface area. Okay, all right, some key ideas is draw a net of the surfaces of the solid to aid in your calculations. So that means, this is something I want you to do every time you work out this surface area stuff, is, like I said before, let's take this pyramid here, and so drawing the net, we've got the square base, then the triangle pieces sticking off to the outside. Okay, it's really important that you're going to be able to do that, to deconstruct this three-dimensional object in your mind and then draw it out. Okay, so that's creating the net from the solid. Okay, so here's the solid, this thing here is the net. Okay, and then you just calculate the area of the net as if it were a composite shape. So for this one, if this was area 1, area 2, you'd go, well, the total area is equal to area 1 plus 4 times area 2. Okay, that's how you go about that one. All right, let's have a look at some examples, probably the best way to go about it. All right, so remember, step 1 for this is to draw a net of it. Okay, so I'll draw it down here. So we've got our top triangle, so that's this one up here, then the long sort of rectangle, and it's joined to another triangle at the other end. Then if we folded these sort of pieces here out, we've got this one here and this one here. Now we're not told, so we're told 5 centimeters, 5 centimeters, 6 centimeters. So not every one of those rectangles is going to be exactly the same. Okay, so it's important that you are aware of that. So we've got here, we're going to call this area 1, and so that's obviously area 1 as well. And then so we'll have area 2 and area 3. This is also going to be area 3. Okay, so that's how we're going to work it out, mapping it out, thinking about it. All right, so our area 1 pieces are equal to the area of a triangle, which is half base times height, perpendicular height obviously, and so that's half 6 times 4, which is 12 centimeters squared. Area 2 is equal to the area of a rectangle, which is length times width, which is equal to, for this bottom one, 6 times 15, which you'll find is 90 centimeters squared. Let me stop. Yes, yeah, 90. Yes. And then area 3 are these side pieces. So that's also area equal to the area of a rectangle, which is another length times width, which is 15 times 5, which is equal to 75 centimeters squared. Okay, so now that we've worked out all these different bits and pieces, we're going to go, okay, our total area for this is equal to 2 times area 1 plus area 2 plus 2 times area 3, which is 2 times 12 plus 90 plus 2 times 75 gives us 2 times 75 plus 90 plus 4 is 264 centimeters squared. And so there would be our surface area for that shape. Okay, let's have another quick look at another one. Okay, cylinder. This one's a little bit more tricky, takes a bit of thinking. Okay, first thing, draw our neck. I'm going to draw this one a little bit larger than the last one. So we've got circles at the top. Then we've got the outside wrapped around. If you cut that and pulled it apart, you had to see that it is a nice rectangle. Okay, and then we've got the other circle for the other side. Okay, so our circles we're going to call area 1, and this will be area 2. Okay, so bearing in mind that these are going to be exactly the same because it's sort of a right prism. Okay, now let's think about what we've got here. So area 1 will be equal to the area of a circle, which is pi r squared, which is equal to pi times 18 squared, which is 1017.9 meters squared. I've worked these out already. I'm not just cranking out pi calculations off the top of my head, in case you thought that was going on. Now, area 2 is equal to the area of a rectangle, which is equal to a length times a width. Now, here's when you need to think about what's going on here. So it's 26 meters tall. So this is this length here. So this is 26, right, meters. But what's going on with this length here? We're not given anything in the drawing. So how do we come about it? Well, if we wrapped it back up, you would find that this wraps up perfectly around the circle, and this is called a circumference. And the length of around the outside of a circumference is equal to 2 pi r, or pi times diameter, which one everyone you go for. So that would be our length. So this will be equal to 2 pi r times the width. So that'll be 2 pi times 18, 2 pi times 18 times 26 is equal to 2,940.5-ish meters squared. So now our total area is equal to 2 area 1s plus area 2, which gives us 2 times 1017.9 plus 2,940.5, which gets us in the end 4,976.3 meters squared. Okay, so that cylinder one's a bit different. So you've got the top, bottom, and the round outside. So you've got to think about the area of circle formulae and the circumference of the circle formulae. Okay, all right, last one. So here we're going to be looking at a pyramid. So this one's a lot more simple than our cylinder. So we've got the square base, then off the outside we've got these 4 triangles drawn terribly, but we're going to call this area 1, and these are all the same because with this kind of square base pyramid, unless you're told anything different, you're just going to assume that all these outside ones are the same. So this is area 1, this is area 2. Okay, area 1 is equal to the area of a square, which is side squared, which is 3 squared, which is equal to 9 centimeters squared. Okay, then we have our triangle. So we're told that this is a base length of 3 down here, and that it's got a right angle going up with 8 centimeters. So 3 centimeters, 8 centimeters, and our area 2 is equal to the area of a triangle, which is half base times perpendicular height, which is half times 3 times 8, which is 12. Okay, now lastly, our total area will be equal to area 1 plus 4 lots of area 2, which is 9 plus 4 times 12, which is equal to 57 centimeters squared. Okay, so sorry for a bit of a longer video, but I wanted to show you the different sort of circumstances you might need to practice this in. So again, with this, practice, because you want to push your spatial reasoning, be able to take a 3-dimensional object, pull it apart into its 2-dimensional surface area. Okay, thanks so much for watching, and I'll see you at school.